Right now, scientists at the UN, at Cambridge, at research centers across 5 continents are all arriving at the same conclusion. The food system feeding 8 billion people is breaking down. Wheat, maize, rice. 3 crops carry nearly half of every calorie eaten on Earth. Every single day. And every one of them is failing under a climate they were never built for. In 2021, one summer heatwave collapsed Canadian wheat production by nearly 40%. One season, one heatwave. The IPCC now projects up to 30% of current crop zones could become completely unsuitable for farming before this century ends. But here is what they are not telling you. While those crops fail above ground, something has been waiting underground. For thousands of years, before Rome, before Egypt, ancient civilizations on every continent farmed a completely different way. Not grain fields stretching to the horizon. Layered, living underground systems. Sacred root combinations, engineered to survive floods, droughts, volcanic soil, and freezing altitude, and still feed an entire people. Climate scientists are now calling these systems the future of food. 10 of them. What they contain, how they were paired, and why modern agriculture is racing to revive them. That is what this video is about. Stay with me. By the end, you will never look at the ground beneath your feet the same way again. Long before supermarkets, before tractors, fertilizer plants, satellite-guided irrigation, there were people who knew how to feed themselves. And they did it brilliantly. Not because their land was perfect. Many farmed on volcanic rock faces in the middle of the Pacific Ocean. Others pulled food from frost-hardened soil at 14,000 feet in the Andes. Some grew harvests in West African wetlands, dry Hawaiian coastal zones, windswept Bolivian highlands, land that modern agriculture would not even classify as farmable. They fed families, communities, empires, and the secret was underground. These civilizations understood something the modern agricultural system spent a century unlearning. The most resilient food on Earth does not grow up toward the sky, exposed to drought, heatwave, storm. It grows down, into the soil, insulated, protected, quietly accumulating energy that no weather event can reach. Roots, tubers, corms, rhizomes, the hidden half of the plant world. In Hawaii, farmers built engineered wetland networks called lo'i to grow taro, a plant so sacred it was considered the literal elder brother of the Hawaiian people. The Hawaiian word for family, ohana, comes from oha, the young shoot that sprouts from the side of a taro corm. Family, rooted in the earth. Not a metaphor. Biology. In West Africa, the Igbo organized their entire agricultural calendar around the white yam. Before anyone could eat from the new harvest, the first tubers had to be offered to the earth goddess, the supreme deity, and the ancestors. Eating early was a spiritual transgression, not superstition. A covenant. The recognition that human prosperity and soil health were the same thing. In the Andes, farmers developed over 300 distinct varieties of a single root crop, selected for altitude, frost resistance, specific soil types, disease immunity. 300 varieties of one plant. That is not primitive farming. That is one of the most sophisticated acts of biological engineering in human history. These people were not farming for survival. They were farming for permanence. Embedded in the combinations they planted, pairs and trios refined across hundreds of generations, was an agricultural intelligence that modern science is only now beginning to decode. Because what those farmers understood, and what climate scientists are urgently rediscovering, is that these root combinations were not just feeding people. They were building systems designed to outlast anything the climate could throw at them. Not dismissed, just buried. The world had made its choice. Wheat, maize, rice. The Green Revolution delivered miracle seeds and synthetic fertilizers and yields nobody had ever seen. Grain production doubled, then tripled. Hunger, it was declared, was a problem science had solved. The ancient root crops, taro, yakan, oca, maswa, were filed away. Regional foods, subsistence crops, things poor farmers in remote places grew because they hadn't accessed modern agriculture yet. The scientific establishment moved on. But something was always there, patient in the soil, waiting. because these plants could do things no cereal grain ever could. And no amount of institutional forgetting changed the underlying biology. Then, slowly, the data began to arrive. A researcher in Peru documenting OCA's extraordinary frost tolerance at 4,000 meters. A soil scientist in Nigeria measuring nitrogen levels in fields where cassava and cowpea had been intercropped the traditional way, inexplicably rich without a single bag of synthetic fertilizer applied. An agronomist in Hawaii studying ancient low-I wetland systems, finding hydrological engineering that modern irrigation designers had never independently arrived at. Each study interesting, each one filed away. Then climate change made it impossible to look away. The IPCC's sixth assessment report landed, the most comprehensive analysis of agricultural vulnerability ever compiled. The verdict: the cereal-based global food system was structurally fragile in ways the coming decades would brutally expose. Heat domes, prolonged droughts, shifting growing zones, rising CO2 actively degrading the nutritional density of wheat and rice. The system that had fed the world for 60 years was heading toward collisions it was never designed to survive. Researchers started pulling old files. What they found stopped them cold. The root crops ancient civilizations had grown for millennia were not just surviving the conditions destroying cereal crops. They were thriving in them. Cassava shed its leaves in drought to conserve water, then resumed full growth the moment rain returned. No cereal crop on Earth does that. Taro grew under completely flooded, anaerobic conditions, waterlogged soil that drowns most crops, and still produced a dense, nutritious harvest. Maca was being cultivated at over 14,000 feet above sea level, in soils and temperatures modern agriculture had classified as impossible for food production. Yacon stored its energy not as starch but as fructooligosaccharides, a prebiotic fiber that passed through the body without spiking blood glucose, quietly feeding the gut microbiome. A functional food, an ancient one. Then researchers looked not just at the individual plants but at the combinations. That was when the real revelation hit. These roots had never been grown alone. Not by the cultures that built them. Always in pairs, in trios, in layered polycultures where each plant served the others, fixing nitrogen, suppressing weeds, blocking wind, shielding against pathogens, extending the harvest across seasons. The ancient farmers had not just discovered resilient plants. They had engineered resilient systems. And modern agroecological science, armed with genomic analysis, soil chemistry, land equivalent ratio calculations, and climate modeling, was arriving one study at a time at the exact same combinations those farmers had practiced for thousands of years. Ancient wisdom and modern science, finding each other across millennia, looking at the same roots, reaching the same conclusions. But here is what the research papers do not show you. What the agroecology journals and optimistic headlines about ancient crops leave out of the story. The collapse is not coming. It is already here. Summer 2021. A heat dome settled over Western Canada. Temperatures with no historical precedent. Crops that had grown there reliably for generations cooked in the ground. Canadian wheat production fell 38.5% in a single season. Not a bad year. Not a below-average harvest. Collapse. More than a third of the crop. Gone. Global grain prices spiked within weeks. Then 2022. The conflict in Ukraine, one of the most productive cereal regions on the planet, removed a critical share of the world's wheat and sunflower oil from global markets almost overnight. Countries across North Africa and the Middle East that depended on Ukrainian grain faced shortages no domestic production could replace. 2 events. 2 years. The fragility of a system built on 3 crops, visible in a way even the most optimistic economists could no longer explain away. But those were the crises that made the news. There is a slower collapse happening underneath them that almost no one is talking about. The IPCC's 6th assessment report contains a finding that received almost no mainstream coverage. Elevated atmospheric CO2, the same gas warming the planet, is actively degrading the nutritional density of wheat and rice as they grow. More carbohydrate, less protein, less zinc, less iron. Every passing decade of rising emissions. We are not just growing less food. We are growing food that is less nutritious. And the people most dependent on cereal staples, the poorest populations on Earth, are absorbing that nutritional loss first. Under high-emission scenarios, up to 30% of current crop and livestock zones could become climatically unsuitable before this century ends. Within the lifetime of children alive today. And the agricultural system's answer? More of the same. More high-yield cereal varieties. More synthetic fertilizers on soils losing their biological structure. More irrigation draining aquifers faster than they recharge. More monocultures, single-crop fields across thousands of hectares, one pathogen away from catastrophic failure. The Irish potato famine killed 1 million people and forced another million to flee. Not because potatoes were fragile. Potatoes are one of the most productive, nutritious staples ever developed. It happened because the entire country grew a single variety. One pathogen. One variety. One catastrophe. The global food system is doing the same thing right now. Planetary scale. 3 crops. 45% of all calories. Narrow genetic baselines. Atmospheric conditions they were never designed to withstand. And here is the hardest part. The alternatives exist. They always existed. Growing in the hands of farmers in the Pacific, the Andes, West Africa, Mesoamerica, farmers who had already solved, across thousands of years of observation and selection, the exact problems climate science is now scrambling to address. Underground crops that survive drought by design. Root combinations that rebuild soil while feeding the people above it. Systems that generate their own fertility, no synthetic inputs required. The knowledge was never lost. It was never listened to. The window to choose a different path is not infinite. The soil is already telling us. The climate data is already telling us. The only question is whether we are willing to hear it. There is a grief in this story that does not get named often enough. It needs to be named. What happened to these ancient root systems, to the knowledge that built them, the communities that carried them, the farmers who spent generations perfecting them, was not the world moving on. Not progress replacing the old with the new. It was a loss. Specific. Documented. Measurable. When European colonial agricultural systems spread across the Pacific, Africa, and the Americas, they did not arrive as one option among many. They arrived as the only acceptable option. Indigenous food systems were not evaluated on their merits. They were classified as primitive, inefficient, the practices of people who did not yet know better. Cash crops replaced food crops. Monocultures replaced polycultures. Flat plowed fields replaced the layered underground systems that had fed communities for millennia. And something irreplaceable went with them. In Hawaii, the ancient Loei taro networks, engineered wetland systems that had supported entire populations on land modern agriculture would classify as marginal, were drained and converted. The 300 distinct taro varieties Hawaiian farmers had developed over centuries, each selected for a specific microclimate, a specific soil, a specific culinary use, were reduced to a handful. 300 varieties, carrying within their genetics the accumulated environmental intelligence of generations. Gone. Not all, but most. In the Andes, the potato fed Europe, enabled population growth that reshaped the continent, became so central to Irish subsistence that when a single pathogen arrived, the genetically diverse Andean potato varieties were specifically protected against. The monoculture collapsed and 1 million people starved. The Andean farmers who developed the potato had never planted a monoculture. They always grew it alongside OCA, alongside Aluco, alongside Maswa, not out of tradition, but because the combination was the protection. The diversity was the defense. The polyculture was the insurance policy. That understanding did not cross the Atlantic with the potato. Only the plant went. The system that made it resilient stayed behind. In West Africa, sophisticated multi-crop yam systems developed across centuries were systematically undervalued in favor of export crops. Groundnuts, cotton, cocoa, crops that generated colonial revenue instead of community nutrition. The spiritual frameworks protecting these systems, the IWAG ceremonies, the restrictions on early harvest, The communal obligations preventing any single actor from depleting the soil were dismissed as superstition. What those frameworks actually were was governance. A biological commons maintained by cultural covenant. Rules that kept soil healthy, genetic diversity intact, and communities fed across generations. Strip away the governance. Strip away the ceremony. Strip away the covenant. What you have left is just a field, exposed to every pressure the market and the climate can apply. Because the people who built these systems were not primitive. They were not uninformed. They were not waiting to be saved by modern agricultural science. They were the scientists, the breeders, the soil chemists, the climate modelers, the food security strategists, doing their work across centuries, in the medium of living plants and cultivated soil without laboratories, journals, or institutional funding. The knowledge they produced, these 10 sacred root combinations, these pairings and polycultures and underground architectures, was not folklore. It was data. Data the modern world discarded. Data the modern world now desperately needs. The solution was already here, tested, proven.
Multigenerational.
In the soil, in the seeds, in the hands of farmers who were told their knowledge did not count. But grief, when it is honest, does not stay in one place. It moves. It looks at what remains. The OCA still grows in the Andes. The taro still grows in Hawaii. The yacon is still on the eastern slopes where it has always been. The cassava-cowpea combination still feeds hundreds of millions across sub-Saharan Africa. Even now, even under pressure, even as the world around it changes. The seeds survived. The knowledge survived. And a new generation of researchers, many of them indigenous, many working directly with communities that never stopped farming these systems, is doing the work of recovery. Not starting over. Returning. It did not happen with a press conference. No global summit declaration.
No viral moment.
No institutional announcement that the ancient root systems deserved a second look. It happened the way real change always happens. Quietly. In the margins. One study at a time. A soil scientist in Nigeria runs intercropping trials. Cassava monocultures against the traditional cassava-cowpea combination local farmers had practiced for generations. The results come back. He reads them twice. The intercropped fields are outperforming the monocultures. Not slightly, substantially. And the soil underneath, the soil that should have been depleted by a heavy-feeding root crop, is measurably richer in nitrogen than when the trial began. He publishes. A handful of researchers read it. A year later, a researcher in the Andes maps which crop combinations appear most consistently across different communities at different altitudes. Pattern emerges. Potato and OCA together almost universally. Potato and maswa, planted specifically at field borders. She asks the farmers why. Their answers are precise, detailed, accumulated across lifetimes, inherited from the lifetimes before. She brings those answers to the laboratory. Maswa contains isothiocyanates, organic compounds that function as a natural pesticide, repelling the exact nematodes and fungal pathogens that devastate potato monocultures. The ancient farmers had not been pairing them by coincidence. The combination worked. It had been tested. For centuries, the laboratory confirmed what the field had always known. In Hawaii, a team of agroecologists partners with native Hawaiian farmers to restore traditional low-I wetland systems on land that had been converted and abandoned. The water channels are rebuilt by hand, guided by archaeological records and the memory of elders who had seen the last functioning systems as children. When the taro goes back into the water and giant swamp taro returns to the coastal margins, something in the surrounding ecology responds. Water quality improves. Native fish species return. Soil compacted and depleted under conventional agriculture begins to recover its biological structure. The system does not just feed people. It restores the land. That is what cereal monocultures never did. They extracted, season after season, input after input, synthetic nitrogen in place of leguminous companions, pesticides in place of natural pest barriers, irrigation in place of the water-retaining root architecture's ancient crops, had built into the soil through their own biology. The ancient systems ran on a completely different logic. Not extraction, exchange. Cowpea fixes nitrogen and gives it to cassava. Cassava's canopy shades out weeds competing with the cowpea. Maswa protects potato from nematodes. Sugarcane shelters sweet potato from wind. Yakon's falling leaves suppress weeds through natural allelopathic chemistry. Every combination is a conversation between plants. A closed loop that produces more than any of its members could alone. Modern researchers measure this using the land equivalent ratio, how much land a monoculture would need to match the combined output of an intercrop system. Across study after study, the ancient root combinations return ratios well above 1.0. One intercropped field outproduces the same area planted with any single crop alone. The ancient farmers did not have the term. They had the result. Then the IPCC report landed. Climate projections became impossible to minimize. Institutions that had spent decades funding high-yield monoculture research began, cautiously, to fund something different. Agroecology programs, polyculture trials, indigenous crop documentation, seed bank expansions targeting the root crops and tuber varieties industrial agriculture had sidelined. The International Potato Center in Lima, quietly maintaining one of the world's largest collections of Andean root crop germplasm for decades, often with almost no institutional support, suddenly found itself at the center of urgent conversations about food security and climate resilience. The OCA, the Maswa, the Aluko, the Maca, specimens in a collection 1 year. Candidates for the future of food the next. Researchers who had spent careers in the margins, documenting traditional systems their institutions rarely considered worth serious investment, found the phone ringing in a way it never had before. The questions were no longer academic. Which combinations perform best under drought? Which root architectures retain the most soil moisture? Which polycultures rebuild nitrogen-depleted soil fastest? Which ancient varieties carry the genetic traits needed to breed the climate-resilient crops of the next century? The answers were already there, written in the soil, encoded in the seeds, preserved in the practices of communities that had never stopped doing what their ancestors taught them. It does not look like a revolution from the outside. It looks like a researcher in muddy boots crouching beside a yacon plant in the Andes. A laboratory in Lima receiving a seed accession from a Bolivian community that had protected a particular Maswa variety for generations. A restored Hawaiian loai producing its first taro harvest in 50 years, while an elder stands at the water's edge and says quietly, "This is how it was always supposed to be." The world is remembering something it should never have forgotten. And it is just beginning. This is what the science has found. Not in theory, not in projections, in fields, soil samples, harvest yields, in communities that never stopped farming this way, and research stations now proving, with every tool modern science possesses, what those communities always knew. 10 combinations, each one ancient, each one confirmed. Here they are. 1. Taro and giant swamp taro. Common taro delivers a fast harvest, 8 to 12 months. But its corms survive only 2 weeks after harvest. Giant swamp taro is slow, but it can remain dormant in flooded, highly saline coastal soil for years. When the typhoon comes, when sea levels rise, when saltwater floods the common taro fields and destroys them, the giant swamp taro survives. It has always survived. That is what it was there for. A living insurance policy buried in the margin of the field. Climate scientists studying Pacific Island food security are now calling this combination a model for coastal agricultural resilience. A system designed specifically for the conditions climate change is delivering, designed thousands of years before the threat had a name. 2. Cassava and cowpea. Cassava, the Rambo root, survives drought by shedding its leaves and waiting. Resumes growth the moment moisture returns. No cereal crop on Earth does this. Cowpea, planted alongside in alternating rows, fixes atmospheric nitrogen directly into the soil, eliminating synthetic fertilizer entirely. The combined canopy reduces destructive whitefly populations by 73% and mealybugs by 60%. Natural pest suppression.
No chemicals. Pure biology.
Field trials confirm this intercropped system dramatically outperforms cassava monocultures in yield, land efficiency, and soil health. It is feeding hundreds of millions of people right now across sub-Saharan Africa. 3. White yam and mucuna pruriens. White yam is a heavy feeder. Left alone, it depletes the earth beneath it season after season. Traditional West African farmers solve this by planting mucuna pruriens, velvet bean, alongside the yam, sharing the same support stakes. The mucuna fixes nitrogen. Its dense canopy suppresses competing weeds. When its pods mature, they deliver a second harvest protein-rich, alongside the primary yam crop. 1 field, 2 harvests. Soil that ends the season richer than it began. 4. Sweet potato and sugarcane. Polynesian farmers needed to grow sweet potato, a tropical plant, in the frost-prone, windswept climates of New Zealand and coastal Hawaii. Modern agricultural assessment would have classified those environments as unsuitable. They planted sweet potato mounds in raised beds mulched with gravel and basaltic rock to trap solar heat. Along the stone field walls, they planted rows of wild sugarcane, not for sugar, for shelter. The tall, rigid stalks intercepted the cold, desiccating winds that would have collapsed the delicate vines. The combination engineered a microclimate, a localized zone of warmth and humidity inside an environment that had no business growing tropical food. Climate-controlled agriculture. Ancient. Using nothing but the biology of 2 plants and the physics of wind. 5. Potato and OCA. Potato blight, the pathogen that caused the Irish famine, cannot touch OCA. OCA is entirely immune. By interplanting potato and OCA in the same mounds, Andean farmers built a physical and biological barrier to pathogen spread. When blight moved through a field, it hit OCA and stopped. Ireland's monoculture had no such barrier. The ancient combination had built one in by design, thousands of years before Phytophthora infestans was ever identified by science. The genetics that make OCA immune are now being studied by plant breeders developing the climate-resilient potato varieties of the next century. 6. Potato and aluco.
Uyuko produces calerfel. Sini skinet tubes requiring no peeling.
Frost-resistant, drought-tolerant, extraordinarily flavorful. But above the ground, it does something that makes it uniquely valuable. Its succulent leaves are edible, rich in protein, calcium, and carotene. Farmers harvested aluco leaves throughout summer for immediate nutrition, while the underground tubers continued maturing toward autumn harvest. 1 plant, 2 harvests. Above ground and underground productivity running simultaneously. Modern permaculture systems are trying to engineer this logic. Andean farmers were already living it. 7. Potato and maswa. Maswa produces up to 70 metric tons of tubers per hectare on marginal soils.
No fertilizer. No irrigation.
No pest management. Ancient farmers planted it as a biological border around potato fields. The reason? Maswa contains high concentrations of isothiocyanates, organic compounds that chemically repel the destructive insects, soil nematodes, and fungal pathogens that devastate potato monocultures. A living border, a chemical defense system, growing at the edge of the field, guarding everything inside it. Modern researchers studying natural pesticide alternatives are now examining Maswa isothiocyanates as a template for the next generation of crop protection compounds. 8. Yacon and quick-growing greens. Yacon takes 3 months to establish. During that window, the field is vulnerable, bare soil, exposed to weeds, losing moisture to evaporation. Ancient farmers intercropped young yacon with fast-growing greens. Rocket, chard, peas. The greens covered the bare soil, suppressing weeds, retaining moisture, until the yacon canopy closed and took over. A temporal relay system, each crop doing its job in sequence, handing off to the next. Soil covered and biologically active at every stage. No synthetic weed management. No bare soil baking in the sun. The system manages itself. 9. Jicama and maize. Jicama is a climbing legume. It needs vertical support to reach sunlight. Traditional Mesoamerican farmers planted it alongside maize and let it climb the rigid stalks. The maize provided the trellis. The jicama's root nodules fixed atmospheric nitrogen, directly enriching the soil the maize fed from. When farmers pruned the jicama flowers and seed pods to force energy into the underground tuber, the discarded foliage, containing rotenone, a potent natural insecticide, was left to decompose on the soil surface, protecting maize roots from burrowing pests. Nothing wasted. Every part of every plant doing something useful. 10. Maca, Acaira, and Mauca, over 14,000 feet above sea level. Windswept Andean puna. Frost without warning. Poor, cold, thin soils. Ancient farmers were growing food here, not despite the conditions. Within them, maca, the highest altitude crop in the world, farmed for nearly 6,000 years, contains adaptogenic compounds that ancient warriors consumed before battle for endurance and strength. Acaira, planted as a windbreak, produces starch granules so large they are visible to the naked eye, extractable with simple household equipment. Mauca, long thought extinct, rediscovered in 1965 in a remote Bolivian community that never stopped growing it. Rich in protein, calcium, and phosphorus, thriving in soils nothing else would tolerate. 3 plants. 3 biological roles. One system feeding a community in conditions modern agriculture has never successfully colonized. The combination was not accidental. It was architecture. The future of food security is not a new technology. It is a recovered one. Underground. In combinations. In the layered, self-sustaining, soil-building polycultures that ancient civilizations spent thousands of years perfecting, and the modern world spent a century ignoring. The window is not closed. The OCA still grows. The taro still grows. The Maswa still guards Andean potato fields in communities that never stopped farming the old way. The seed banks hold the genetics. The researchers are in the fields. The indigenous communities who carried this knowledge through every pressure to abandon it are still here. Still farming, still willing to share what they know with a world that is finally ready to listen. The soil remembers what the system forgot. Go back underground. Learn from the farmers who never needed a climate crisis to tell them that roots were worth protecting. There is still time to build food systems that do not break, to grow food that rebuilds the earth it grows in, to feed the next century the way the ancient world fed itself. Not by extracting from the land, by entering into covenant with it. If this changed how you think about the ground beneath your feet, hit like right now. Share it with someone who needs to hear this story. And subscribe. Every week this channel goes deeper into the intersections of ancient wisdom, modern science, and the future that is still possible. The next video goes even deeper underground. I will see you there.